In this video, we are going to solve WB Set 2022 question from integral equation. Well, questions from integral equations are not that hard in this year, but sometimes a little bit tricky and sometimes a little bit calculative. Okay, but you have to use the proper short trick. Every time, use the proper short trick to save your time. Okay, so first all you have to do is classify any given integral equation and then classify the given kernel of that integral equation and then try to solve them. Okay, so let's start. You can see this is a non-homogeneous Volterra integral equation with convolution kernel. What is convolution kernel? See, kxt is equal to some function of x and t, which can be represented as a function of x minus t. Right? This is a function of x minus t. X minus t is a variable right here. This type of kernels are called convolution kernel. When you see that there is a convolution kernel in a Volterra type integral equation from 0 to x, you have to apply Laplace transform to solve the equation. Okay. Now take Laplace in both sides of the equation. It will become L of phi x is equal to L of this 1 minus 2x minus 4x square plus L of integration of this whole thing. Okay, I have written f of x minus t right here. Okay, now you know, according to convolution theorem in Laplace equation, L of integral of 0 to x f of x minus t phi t dt will be what? L of fx and into L of phi x. Okay, x minus t is replaced by only x and phi t is replaced by only x again. So this is convolution theorem from Laplace transform. Also, when you apply Laplace, you know that Laplace function is linear. Okay, so you can break it into three parts, which are L of 1 minus 2 into L of x minus 4 into L of x square. Now there is a formula for Laplace transform, which is L of x to the power n is equal to n factorial over p to the power n plus 1. And if you put n is equal to 0 right here, in this equation, it will become L of 1 is 1 over p. Okay, since 0 factorial is 1. So now you will apply Laplace transformation directly on this after breaking this part into three equal parts. Okay, it will become 1 by p minus 2 into 1 by p square. Here we put n is equal to 1. See, x to the power 1, L of x to the power 1. So after putting here n is equal to 1, you will get L of x as 1 over p square. So I've written this. Similarly, it will become 2 over p cubed and 4 minus 4 as it is. Okay, so now in the next line I have written the value of fx, which is 3 plus 6x minus 4x square. Why? See, here f of x minus t was this function. Okay, now if we put x minus t, if we put x in place of x minus t, this will also change into only x instead of x minus t. So I have written here x instead of x minus t, since it is function of fx. Okay, so now apply these formulas when you're using Laplace transform to get this line. Now, since there is L of phi x right here, okay, and the same L of phi x at the LHS, so take this one, take this whole term to the left side, and it will become L of phi x, and when you take L of phi x in common, it will become 1 minus this whole thing. Okay, so I've written this, and what remains at the right side is this. I have written this in terms of I have written this I have added these three terms. Okay, now in the next line, add these four terms. So this p cubed get cancelled with this p cubed. Okay, now factorize the numerator right here, which will become p minus 1 into p square minus 2p minus 8. And at the right side, there is also some p square minus 2p minus 8, which will get cancelled out. So L of phi x will become 1 over p minus 1. Take this p minus 1 to the right. Okay, so phi x is equal to L inverse p minus 1. Now we know that L inverse p minus a, 1 over p minus a, is equal to e to the power ax. So here value of a is 1, so we will get e to the power x. Okay, so this is our result, phi x, and this is our solution, phi x is e to the power x. So we are asked to find the value of phi of log 2. Okay, so phi of log 2 is e to the power log 2, which is 2. So the answer is C, which is 2. Now let's go to the second problem, which is question number 61. Now this one is a little bit tricky. You have to use a short note that I will provide you. So the whole question reduces to only 2 or 3 lines. Okay, only 2 or 3 lines. And the note is, if we know that kxt is the kernel right here, which is e to the power t minus x. If kxz into kzt is equal to kxt, if the kernel follows this formula, then the resolvent kernel rxt lambda will become kxt e to the power lambda into x minus t, where lambda is what? The eigenvalue. Here lambda is, there is no lambda, so lambda will be 1 right here. Okay, and kxt is e to the power t minus x. So now let's check if our kernel follows this equation or not. Kxz into kzt is what? K to the power z minus x, k to the power t minus z, which will be k to the power t minus x. That is kxt, we get back kxt again. So from our note, our xt1 will become kxt into e to the power lambda into x minus t. That is e to the power t minus x into e to the power x minus t, which will become 1. So the right option will be B, that is 1. Okay, so this is our complete solution on integral equation. Okay, thank you, and don't forget to like, share and subscribe.